Hello everyone and welcome to Vedantu's CBSE midterm review. Okay, I am going to be your master teacher Kunal, and whilst everyone is joining this webinar this evening, I would just quickly run down through the instructions that I'd like to follow in this webinar. Okay, whilst everyone is joining. Number one, which is a very important point, is to please make sure to carry a notebook and pen, not just in this webinar, but also in all other classes that we're going to have after the webinar is done and once you guys join the master classes. Okay, the reason I'm asking you to do so is because we're going to solve a lot of problems in-house during these sessions. Not only that, I'd also be giving you a few tips and tricks to solve all the problems in your examinations quickly and in the right procedure, and also have a quick check of whatever you have done to make sure that you have followed the right procedure and you have made the right decision of solving the problem, or basically the right methodology. In such cases, you can note down those points in your notebook instead of writing down notes, everything whatever is discussed in the classes. So that's not needed. But the notebook and pen is to jot down important points and to solve a lot of problems during the sessions, because I'm going to do that. Okay, we're going to have a lot of problem solving sessions because that is the most important part about mathematics, other than obviously understanding the concepts. Cool. Second point, I think many of you are logging in through your laptops or mobile phones or desktops, etc. It is highly recommended that you use your earphones and your headphones slash headphones, because it prevents noise dispersion and there might not be a background positive feedback from your end or from my end, and it might not distract this webinar session. Cool. So whilst everyone is joining in, I highly recommend you guys to quickly go and bring a notebook and a pen before we start. We'll wait for about 1 minute for the others to join in and then we'll go ahead. Cool. So important point for me to tell you one more is that in case if you are logging in from your laptops slash desktops, please keep your phone at least on vibrate mode so that if you have an important call, it does not disturb the class. So if you can't keep it on silent mode, vibrate is cool as long as it does not disturb the others. In case if you're logging in through your mobile phones or from your tablets, then I think it does not make any sense to put it on vibrate or silent mode. Okay. So we'll just wait for another 30 seconds before we start. Alrighty then, let's start. So before we start, I'll give a quick introduction. I guess you guys need to at least know who's going to take your classes and a little bit briefing about me. So hi guys, again, I'm Kunal Das and I'm going to be your master teacher for this webinar and for the sessions that are going to be held later on. I basically hail from Calcutta, from the place of Rabindranath Tagore, Shantiniketan. Currently, I live in Bangalore. A quick run through of my background. I completed my bachelor's and my master's degree in the Department of Electrical Engineering from IIT Madras, and I was a gold medalist in 10th standard when I wrote it in my 2011 in mathematics, because I scored a centum in my school. It has been close to 2.5-3 years now that I'm associated with Vedantu and have been teaching mathematics to CBSE, ICSE and JEE boards as well. So that's a quick run through about me. There are a lot. I think this is just a basic introduction about me. There might be a few cases where we have to interact a lot, so I might not be able to remember everyone's name. I beg your pardon for that. I take a little extra time to remember everyone's name, but I'm pretty sure during the sessions when I interact to each one of you one-on-one, or when we solve problems or me clarifying some doubts, we'll get to know each other a little better. Okay, so that was a quick background about me. Without further ado, let's start. The reason I was given the choice of start taking a chapter to make you understand, this webinar was given to me with a chapter in my mind, and over the past 2-3 years, and including when I was a student of class 10th and 9th as well, I found that similarity of triangles is one such concept which a lot of students usually face problems. Okay, so I decided that this might be the perfect chapter to make you realize how a tough chapter, or sorry, a so-called tough chapter can be solved in the easiest way possible, as long as you understand the concept and make, or rather draw, the appropriate diagrams. Understanding concepts and drawing diagrams are the way to solve any similarity problems, and I'm going to show you exactly how. Okay, this webinar is just going to be about how to solve these problems. So without further ado, let's begin. Before we start solving problems, just a brief introduction of what is going to be covered in similarity of triangles and everything else. In this case, we would have ideology of similar figures, similarity of triangles, what are the important criteria about similarity of triangles, which is considered to be the most important thing. We are also going to see how the area of similar triangles are related, and finally the easiest topic of all, the Pythagoras theorem. This is the easiest, so I have kept it for the last. Cool? Now, a brief idea. I'm assuming in case of you, most of you already know what similarity of triangles or similar figures are. For those who don't, a quick idea. Similar is completely different from congruent. How I picture it is, I picture it in a real life situation. Congruent figures are equivalent to identical twins. What do I mean by that? They look exactly the same. Similar figures, on other hand, are identical to you looking like your parents. I'm pretty sure many of you must have already heard this from one of your relatives, that you look like your father, or you resemble your mother, your nose resembles your grandfather, example, etc., etc. So this is a perfect analogy to explain similar figures. You are similar to your mom, or you are similar to your dad because of some traits, because of your facial expressions, or some part of your face or body that resembles like your dad or like your mom, etc. Okay. So this is the best example of similar figures. You are not same, you are similar. But in case of an identical twin, there is a very, very, very minute chances that they might be different. I'm talking about twin, true identical twins. So whenever you get confused, what is similarity of triangles and what is congruency of triangles, the difference? Remember, congruency means identical twins, similarity means you resembling your parents, etc. Cool? Very easy way to remember this, and I have found out that many of my students have find it easy to remember it whenever this is circle 2, this is circle 3, this is circle 4. All these circles are similar, but if you notice, maybe a little bit, 2 and 3 are not just similar, they are congruent. So this is the difference. Okay? We will come to the criteria of what do you mean by similar triangles, or what are the criteria for similarity of triangles, and we will discuss them later on as well. Not just in this webinar, but also in the other sessions. Okay, the most important criteria of any polygons, be it a triangle, a quadrilateral, pentagon, hexagon, etc. to be similar are, number 1, their corresponding angles are equal and their corresponding sides are in the same ratio. These two are the primary criteria for any figure to be similar. Not congruent, similar. For congruent, they just don't have to be in the same ratio, they have to be exactly the same. That is the difference. But you don't have to remember the difference right now. All you need to remember is that the angles, corresponding angles is the word I'm looking for. Corresponding angles are equal and the corresponding sides of the two triangles are in the same ratio. This is the two major factors by which you can identify which two polygons are similar. Okay? I hope everything is registering in your head. As I mentioned, corresponding angles are equal, corresponding sides are in the same ratio or proportion, whatever you would like to call it. Okay? Keeping whatever I just said in mind, I would like you to just go through this problem and solve it. 1 minute, not more than that. It's a very simple problem and I'm pretty sure many of you will have gotten this. Okay, I'm getting a few. Okay, that's right. That's correct answer. That answer is also correct. Okay, few correct answers. Not bad. Very good. People are understanding. Hopefully, yes. It's a pretty simple problem. Okay, so for all those who have said option D is the right answer, good job. It is. we need to state whether the two quadrilaterals are similar or not. What are the two criteria to remember any polygon are similar or not? Their angles have to be same and their sides have to be proportionate. If we notice here 3, 3, 3, 3, 1.5, 1.5, 1.5, 1.5. So if you take the ratio of any side, all of them are in the same ratio. So that criteria is being satisfied. Okay. But if you notice, these are 90-degree angles, but this being a rhombus, it is not equal to 90 degrees. So the angle criteria over here is not being satisfied. So I cannot say that these two quadrilaterals are similar. So they are not similar because the angles are not proportionate or / equal. Okay. So option D is the right answer, guys. Good job. Many of you have gotten this correct. So I'm assuming the basic idea of similarity is quite clear. Now let's go back and look at few of the theorems and how to solve problems while applying this theorem. The major factor where people lose it. Okay. I'll show you how easy it is. Let me just take an example and then try to make a relevant idea as to what theorems to be applied. For example, if a line intersects AB and AC of a triangle ABC at D and E as shown in the figure respectively, and it is parallel to BC, DE is parallel to BC, I need to prove that AD by AB is equal to AE by EC. Whilst I know there are a variety of students over here who take their own pace to solve a problem, given the time, not just in this webinar, even in your examination is limited to a few minutes per problem. We are going to follow the same pattern in this webinar as well. I'm going to assign a maximum of 2.5 to 3 minutes to solve this problem, which should not take more than that, because if your theorems are clear, it's a very easy problem. Okay. So I'm going to give you 2 minutes starting right now. Go ahead, try to solve the problem and see if you get it. Okay. Okay, 30 seconds extra. I'm getting a few answers already. Okay. Not sure of that answer that was just posted though. Okay, let's see. Okay, let's see how this problem is done. Okay, before we solve any problem, whenever it comes to triangle, similarity, mensuration, etc., basically when we are talking about geometry, the first most important part about solving the problem is diagram. Okay, in this case we have the diagram, so that's good. But in case if the diagram is not given, drawing the diagram is a must. Okay, I'm writing it down specifically because it is of that importance. Drawing a diagram for geometry problems is a must. Okay, because it helps you picturize what you're trying to do or what is the question asked. Okay, maybe if you try to picture it in your head, you might get confused, but actually putting pen on paper and drawing the figure really helps. Okay, personal experience speaking here. is a must. Okay, so now let's look at the problem. They have given that DE is a line that is parallel to BC. So I know of the theorem, the two theorems basically, that if a line is parallel to another line of a triangle, then this line divides the two other sides in equal ratios. That is a theorem that is given. Not only that, we also know the converse theorem. Basically, the theorem is over here, that if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. In this case, in this problem, we are using the converse of that. That if a line is parallel to the third line or the third side, then the other two sides are being divided in the same ratio or same proportion. That is exactly what we are going to do here. Given that this line is parallel to this line by the theorem stated, I can clearly prove it. I can clearly state that. Okay. Now, not just this. What is AB? AB is nothing but AD plus DB. Okay. So what should I do? I need to make an addition. So first thing what I do is reciprocate the entire thing. So now I have DB. This is equivalent of saying DB by AD is equal to AE. Sorry, my bad. EC by AC. Next step would be adding 1, which I think a few students have done it correctly. If you add 1, you get DB plus AD by AD is equal to EC plus AC by AC. DB plus AD, DB plus AD, this is nothing but AB. Same way, EC plus AE is nothing but to say AC. Okay, so now AC, AE. Okay, now I have, just writing it over here, AB by AD is equal to AC by AE. Again, taking the reciprocal of it, I will finally get the result to be AD by AB is equal to AE by AC. Hence, proved. Okay, pretty simple problem as long as you remember the theorem and apply it correctly. Okay, few people might have forgotten the theorem. All the theorems will be discussed, not just for this chapter, for any other chapter that we do as well. This are how everything is going to be discussed and solved during the regular sessions as well. Cool. I hope things have made sense. The solutions are already given here. These can be downloaded. So there's no need for you to copy down the answers. The notes can be downloaded. Okay. Theorems, methodology is the most important factor in solving similarity problems. Cool. This was an easy kind of a problem. Let's look at a little bit tougher problem. I wouldn't say tougher, a little moderate, a little extra level higher problem. Okay. Given that this is a little bit of thinking to involve, I will give you an extra minute. Instead of 2 or 3 minutes, I'll give you 4 minutes to solve this problem. Guys, go ahead. Last 1 minute, guys. Quickly wrap up the problem in case if you have figured out how to do it and you're just writing the steps down quickly. It's a fun problem and you'll see why. Okay, let's see how this problem is done. Here comes why I had earlier stated that drawing figures is of utmost importance. If you guys have drawn this figure like this, problem solved. 90% of your problem gets solved right there. I'm pretty sure as soon as I drew the line AC, if not all, most of you might have already figured how this problem is done. Okay. We already know that EF is parallel to DC and AB. Okay. Now, if I look, I have two triangles. One triangle is ADC and the other triangle is ABC. Okay. So if I look at the triangles, let me call this point as P. AEP and ADC triangles. If I look at these two triangles, this is parallel to this. So I have AE by ED will be equal to AP by PC. Correct? Because of the theorem that I stated earlier. Now, same thing, look at this triangle ABC. But now look ulta. Turn your head upside down. You will see that in this triangle, this is parallel to this. So, CF by BF is equal to CP by AP. Okay? Now, if I just rewrite this, I will get BF by CF is equal to AP by PC. Let me call this 2, let me call this 1. From 1 and 2, I can easily say that AE by ED is equal to AP by PC is equal to excuse me, BF by FC. Hence, AE by ED is equal to BF by FC. Hence proved. Okay, pretty simple problem, but the triggering point in this problem was the drawing of this line AC. Once that line is drawn, it is simple. Not just that line, you could have even drawn this line. In that case, you needed to take the triangles DAB and BDC and figure the problem as on your own. So either cases, both the figures are same and gives the same result. Cool? As you can see in this case. Okay, let's move on and solve a few more problems. Now come the important criterias. I'm assuming a lot of you already know the criterias. The angle criteria or angle, because in a triangle, if two angles are similar, the third angle also has to be similar. Okay, not just similar, equal, same, anything you use it. The other thing is the side. This is not evident. Okay, if two sides are same, the other side has to be same. It does not have to be like that. Isosceles triangle does not imply, isosceles triangle does not have to imply equilateral triangle, but equilateral triangle does imply isosceles. Okay, remember that concept. And finally, where many of you guys make a mistake is the SAS, side angle side theorem. Okay, why people could have written it SSA as well, but why do we write SAS? Ever wondered? Because this is a way for the mathematicians to tell you that the theorem states that according to the theorem, the angle has to be included between the two sides that are equal. I cannot just take randomly any side. It has to be the angle which is included between the two sides that are equal in both the triangles. That is the reason why angle is written between the two sides. Included angle. And you will understand the importance of this when we solve many other problems, not just now, but in the regular classes as well. Cool? Few theorems are there, but that's the whole point, as I said. Okay? Let's go directly to the problem and see how this problem is basically solved. This is the best example to solve this problem. Go ahead and try to solve this problem from the three criteria that we had just earlier said. Okay? In case if you're unable to solve it, I will explain the criteria and solve the problem as well. But take about 2 minutes to try to solve this problem. Guys, go ahead. Okay, let's see how the problem is done. Okay, few more. Okay, I'll give you an extra 30 seconds. Okay, I'll just solve the problem. Okay, first, let's see what's given in the question. PQ is parallel to RS. That is given to me. So PQ is parallel to RS. I need to prove that triangles POQ and triangle SOR are similar. This is the way similar triangles are written. I hope everyone is clear there with that. That's the symbol for similar triangles. Okay. Now let us look at the two triangles POQ and SOR. If you notice, given that this line is parallel to this line, this angle is equal to this angle. Okay. Why can anyone say that? Because they are interior alternate angles. Perfect. Correct. Same way, this angle is equal to this angle. Interior alternate angles. Two triangles, this angle is equal to this angle is equal to this angle. Interior alternate angles. Okay. So now I have already proved by angle criteria the two triangles POQ by angle criteria. POQ is similar to triangle ROS. For the perfectionist out there, if you wanted the third side equality as well, POQ angle, let me just change the color for you to understand better. POQ angle is equal to ROS angle, vertically opposite angles. So by angle criteria or by angle criteria, either ways the triangles are similar. Pretty simple problem as long as you remember the theorems. That's the most important part. Okay. Looking at the figure, and this is the reason why drawing figures are of utmost importance. Try to find the value of P. Now, before you guys say, ki, sir, this is this value, I would recommend you to look at the picture, think for a second, and then solve the problem. It is a very simple problem. And I gave this question, even though it is very simple, because I know half of you will make a mistake there, and I will show you why. Okay, this problem is to point out why it is important to draw figures. It's a very simple problem, but 1 minute to solve the problem. Okay, 1 minute is up. Now, those who directly said, I know sir, the angle P is equal to angle B because they are similar triangles and I can easily say this is 60 degrees. Wrong. Why wrong? I'll tell you why. First criteria to see is what? You need to see if the angles are corresponding, correct? Let us look at the corresponding sides. Just because the figure is drawn like this and this does not mean that P is corresponding to B, A is corresponding to R and C is corresponding to Q. No. There are values given for the side. Figure out the perfect ratio and then go ahead with the problem. Okay? Let's see what is given. I have been given AC as root 3 and PR as 6 root 3. So let's see if AC by PR, what it will give me. It will give me 3 root 3 by 6 root 3, which is equal to 1 by 2. Okay. Now let us look what AB and RQ gives. AB and RQ will give me 3.8 by 7.6, which is equal to 1 by 2. Awesome. So PR is corresponding to AC and AB is being corresponding to RQ. Let me change the colors. Then automatically this side corresponds to this side. And if you see 6 by 12 is 1 by 2. So if you notice this figure, one of the figures have to be changed so that you can imagine the figure properly. That is where drawing the figure in similarity of triangle plays vital role. Just because two triangles are similar does not mean any side is similar to any other side and any angle is similar to any other angle. Okay? No. So I need to redraw this figure in such a fashion. Let me redraw this figure as this. Okay? RQ was corresponding to AB. So this becomes R, this becomes Q with 7.6. PQ was corresponding to BC. So I have Q here, this will be P, this will be 12 and this will be equal to 6. Cool. And PR will correspond to AC, which is nothing but equal to 6 root 3. Now this figure is proper. R corresponds to A, B corresponds to Q, P corresponds to C. Correct? So now if this is 80, this is 60, C will become 40 and accordingly P will also become 40 degrees. So the angle value is 40 degrees and not 60 degrees. I hope this made sense to everyone and everyone just didn't rush to get the answer. Figure, guys, I'm repeating. Drawing figures is a must. Okay? Let's move on. Similar kind of problem that we have done. That's why I'll give you only 1 minute to solve this problem before we move ahead. Go on, solve it. Okay, time up. Let's solve. So what is given to us? OA into OB is equal to OC into OD. So let us take two triangles. In triangles AOD and triangles OCB, okay, we are given OA into OB is equal to OC into OD. If I look at the figures, I get this rough idea. I can get OA by OC, which is equal to OD by OB. Okay, this by this is equal to this by this. So I can clearly state by these two sides that they are similar. No, I have been given the ratio. Okay, just because I have been given the ratio does not mean I can directly prove that they are equal. Okay, I can just say for right now that OAD and OCB triangles are similar, but I need to look at the angles that are corresponding. I know that this angle will be equal to this angle. Why? Vertically opposite angles. Perfect. That is correct. Okay. Now they are saying I need to show that angle A is equal to angle C and angle B is equal to angle D. Okay. Now, because of the similarity criteria that I just proved right now, I can from this I can clearly state that because the similarity criteria has been proven, if I just separate out the two figures and write it like this, OCB and OC corresponds to OA. OAD, this is similar to this is similar to this, and this angle is equal. So if you compare, if you write this figure in this fashion, you can clearly state that this angle, let me change the color, this angle is equal to this angle. Similarly, as O equal to O, A is equal to C, then according to the angle criteria, this angle is equal to this angle, which is B is equal to D, A is equal to C by angle criteria, given that the triangles are similar. Okay, this is how you know the theorem. You use the theorem in the reverse ideology. Okay, here the theorem is being asked, given the triangles are similar in the fashion, they don't directly say it, they give this fashion. They're trying to say, I am telling you that the triangles are similar, use and think which property, or rather which criteria to use to prove that A is equal to C and B equal to D. In our case, we use the angle criteria because I know one angle is equal to another angle through vertically opposite angle formula. Cool. Let's move ahead. This will be the last problem in this criteria problems. Then we will shift on to area criteria problems. Okay. This problem is, I think it came in 2013 CBSE Class 10th as well. So this is a good problem that is given. I just want you guys to solve this. I think 2013 or 2014. I'm not too sure. One of the years it came. 2 minutes max. Come on guys, quickly. Okay, I guess I'll give another 30 seconds and then after that I'll solve the problem. Okay, let's see how this problem is done. Now let us look at what the question says. A girl of height 90 centimeter, the girl's height, in this case CD, is equal to 90 centimeter. Let me write down the data over here. Is walking away from the base of the lamppost. She was initially here, now she's walking away at a speed of 1.2 meter per second. Given that this length is equal to 3.6 meters, okay, let me call that AB is equal to 3.6 meters. Find the length of a shadow after 4 seconds. So I know they're asking me after 4 seconds. So from that I can understand from point B how far the girl has traveled, because I know speed is equal to distance by time. So I need the distance. So speed is 1.2 into time is 4, that is 4.8 meters. After 4 seconds, she is at point D. Let us assume she is at point D. So BD length is equal to 4.8 meters. Okay. They are asking me to find the length of her shadow, which is nothing but equal to DE. Her shadow will obviously be this and not this. They are asking me to find this value. Given CD is nothing but equal to 90 centimeter and this is 3.6 meter. Once you have drawn the figure, written down the proper values over here, I'm pretty sure many of you have already gotten the idea. Assumption over here, this first important thing, this is something that I want you guys to write, even though it is quite obvious. Assumption, even in your exams, if you ever get such a problem, assumption is that the lamp and the girl are parallel to each other, standing straight on the ground. This is an assumption that has to be written. Assumption or assuming girl and lamp are parallel to each other, standing on the ground. Okay. This will not give you any extra credit, but the person who corrects your paper will get an idea that you have understood the problem, and that is the reason why you are making this assumption. And this will help the evaluator. This will actually build a good conscience in the mind of the evaluator, so that later he will understand that this kid is a good person. He knows the problem well and is able to solve the problem better. Okay. This is the reason why. These are a few tips and tricks you need to remember. This is the way of presenting your thing. It's not that if you write this or if you don't write this, you're going to lose any marks. Okay. You're not going to get any extra marks for writing this. But subconsciously, it builds this thing into the invigilator's head. Sorry, not the invigilator, the evaluator's head. So these are the tips and tricks I want you to remember. I'm going to give you a lot of such tips and tricks later on in the regular sessions as well. So make sure you register for that too. Okay. So 4.8. Now, as these two are parallel to each other, going back to our first theorem, because this CD is parallel to AB, I can clearly state that. Not just that. I can even prove that the triangle CDE is similar to triangle ABE. Okay. What am I saying? I'm trying to prove that CDE triangle is similar to triangle ABE. How? Angle E is common for both. Okay. This angle is equal to this angle because corresponding angles. If there is two parallel lines, then this angle is equal to this angle by corresponding lines. Same way, this angle, maybe I'll change the color. This angle is equal to this angle. Okay. Corresponding angles. Basically, this is corresponding to a figure like this. Okay, so this angle is equal to this angle. This is common. That's what I said. This is common to both the triangle big and small. And finally, this angle is equal to this angle. So by angle criteria, these two triangles are similar. Because of the triangle similarity property, I can now state that CE by AE is equal to CD by AB is equal to ED by BE. Okay. Now, given that this figure is already gotten for us, now let us quickly see what it is. I know the value of AB. I know this. I know CD. I don't know ED. Let me call the ED to be found as X. Okay. And BE is nothing but 4.8 plus X. So I will take these two values. This does not make any sense right now to take that value. So 3.6 meter. Okay. If I convert that into the centimeter, that will be multiplied by 100. 360 centimeter by 90 centimeter. Okay. I am taking AB by CD, that will be equal to, or rather, if I have to take this, okay, sorry, let me just take this, exactly this figure as it is. CD, that's 90 by 360 is equal to X by 4.8, or rather everything is in centimeters. So that is 480 plus X. Okay, now I need to find the value of X. This is 1, this is 4, cross multiply, I get 480 plus X is equal to 4X, 3X is equal to 480, X is equal to 160 centimeter, or X is equal to 1.6 meters. Okay, simple problem. So the height of the shadow height of the woman after 4 seconds will be 1.6 meters. Pretty simple problem as long as you have understood the concept properly, drawn the figures and written it properly. Okay. Now, let us look at a few problems on how to solve area problems. Okay. There is also a theorem for area. There is only one theorem for area. Okay. That I will show you while solving this problem. But before that, quickly, for those who remember it, try to solve the problem. For those who don't remember it, see if you can remember it and try to solve the problem. Pretty simple problem. How much minutes should I give you for this? Let's see. I'll give you 2 minutes for this. Come on guys, quickly, 30 more seconds. Easy problem. I already have the value in my head. Okay guys, before I give the solution to this, I'll quickly run through an important thing that I have to mention over here. I hope all the tips and tricks that I have given you, I think I've given you 2 tips till now, one the assumption problem and one more before of how to quickly write the formula. These are just a basic example of how, or the different tips and tricks that I basically give to all my students of how to crack their examination, and it has been really effective for the past 2 years. That's the feedback that I have gotten. Okay, I'm not saying that these tips and tricks will help you solve the problem in a better fashion. It will. What I'm trying to say is you solve the problem in different methods. One problem might have 5-6 different methods, but these tips and tricks will help to see whether the problem that you have solved actually has the right answer or not. A shortcut method. Okay, just to check, like something that you do on the rough quickly, that will hardly take you 1 to 2 minutes, and then you can see. And other such techniques where, you know, which will help you garner more brownie points in the head of the evaluator, so that you definitely get more marks. That's always that you want. Okay, other than that, as I said, while solving the problems, I will also be discussing a lot of theory, not a lot, the important part of the theory in a very easy fashion, so that you don't have to remember the theory, but it stays in your head while solving the problem. Okay. Before we start on Pythagoras theorem, quickly tell you the answer for the solution. XY is parallel to AC. This quickly gives me an idea that they are similar triangle properties have to be applied, and it is dividing the triangles into 2 equal areas. So what do I mean by that? If this is Y, BXY, if the area of BXY is A, let me just not call this A, let me call this A1, then they're saying that AXYC is also equal to A1. So what will be the area of triangle ABC? Area of triangle ABC will be equal to A1 plus A1, which will be equal to A1 plus A1, which will be equal to 2A1. Okay. Now, because XY is parallel to AC, I can prove that triangle ABC is similar to triangle BXY. How? Angle B is common. Angle X is equal to angle A. corresponding angles because of two similar triangles. Same way, angle Y is equal to angle C by corresponding angle theorem. So triangle ABC is similar to triangle BXY. Now I know that AX by AB, not AX by AB, BX by AB, the whole square is equal to area of the bigger triangle, area of ABC, then area of the smaller triangle. In this case, area of the smaller triangle, that is BXY by area of triangle ABC. In this case, I know area of triangle ABC is equal to 2A or 2A1, and the area of BXY is only A1. So I just write the value over here as BX by AB is equal to A1 by 2A1 under root, which will get cancelled. So I have BX by AB is equal to 1 by root 2. But I need the value of AX by AB. So what do? I subtract 1 from both the ends. Remember the problem where we added 1? Here we subtract 1. So 1 minus BX by AB is equal to 1 minus 1 by root 2. AB will come to the numerator, minus BX by AB is equal to root 2 minus 1 by root 2. What is AB minus BX? That is equal to AX by AB. So this comes if you remember the property that the area of any triangle, the ratio of the area of two similar triangles is equal to the square of their corresponding sides. Okay, ratio of their corresponding side ka square is equal to the ratio of their areas. This is the theorem. There's only one theorem that exists. Okay. Now, quickly shifting to Pythagoras theorem. I'm assuming everyone is well aware of Pythagoras theorem, so I'm not going to discuss in the next session before we start our main classes. Okay. Let me just quickly solve this. A ladder is placed against the wall. Diagram. A ladder is placed against the wall. This is 2ab square plus bc square. Okay. So this is what I need to find. That is x square is equal to 6 square plus 2.5 square. So given the fact that I am not a great mathematician, I will use the calculator quickly to tell you the answer. That is 36 plus 6, that's 2.5, right? This is 2.5, not 25. That's 6.25. Square root of that will give me 6.5. Okay. So this is 42.25 meter square. X is equal to square root of that, which is equal to 6.5 meters. Okay. So the length of the ladder is equal to 6.5 meters. Pretty simple problem because it's basic Pythagoras theorem.